I'm representing Intel today. Since a number of my colleagues could have been here, I'll just briefly introduce myself. I've been working in high-performance computing all my career and have been privileged to be part of probably about 10 computer system developments from the ground up, notably before my time with Intel, the SGI Challenge machine, Origin machine, and most recently Altix machine. But today I'm going to talk I have 2 points I want to make, and it's really a result of my work with the Intel team in the last year, looking at various software vendors, from large and important ones in HPC to small ones in HPC, trying to do business. Our community isn't always so friendly to software developers in HPC. We like to solve problems ourselves. We have a lot of do-it-yourself think, and I think it's tough to form a software business in this space. So I have a few comments on that theme, really to convey 2 ideas: how we can expand software business and see more traction there, and then a couple of technologies that can really bring new opportunities for anyone doing software development in this space. So first one, expanding the use of HPC methods. I mean, the industry has been good at technology advances, making more and more possible at lower price points. We've really been driving that down. But what emerges at those lower price points? I mean, this set of people in this room are thought leaders in HPC. I mean, we tend to focus on the big systems. So how does that trickle down to profitability in the volume space? I think this is a challenge for a company who wants to sell software to us or independent of us, how this technology bridges from lab out to commercial reality. That's a challenge for the small software vendors to incorporate new technology. We also think of the volume space as driving a lot of the profits and dollars. How do those new users who are going to use those volume products, they need more approachable, simplified software. The last speaker commented that his users were not software developers. Many of the teams in this room have users who are software developers. To see a software company sell a product, their users are not developers. They need approachable, usable software. And as I've worked with software vendors over the last year, that's often a challenge for them to think about how they address the volume space, make their products more usable. Myself, I've enjoyed video editing for the last 10 years. And 10 years ago, it was tough to do video editing. It took a lot of expensive gear. Today, of course, you can do a reasonable job on your cell phone of video editing. Although features get more limited, but capabilities are there. And those features get tuned, and the volume space is addressed, and you make money there. But the feature set has to be tuned to that space. So software is a business. You can't build this without a motivation or something to fund it. Hardware is not funding much software these days. As I've worked with a number of hardware partners trying to see how they can strengthen their business in HPC, they can't. It's sad. I see less and less software development occurring in our industry driven by traditional hardware vendors. It's getting really thin. And so if we think about that, we wonder, where does software of the future emerge? We might wonder in the last, say, 10 years, what major package has jumped out afresh or anew or really come to the attention or gained a large user base. There's not been a lot of movement in recent times. I think we need to think about how to make that happen. I sort of paraphrased the famous bank robbers thing here. Why do developers rob banks? I sort of mixed 2 metaphors or something there. Where does a developer go to make money now? Where does the future simulation software come from? Well, if you want to learn more about cracking materials and bending things, I hope it's not in the next version of Angry Birds or something, but that's where the developer's finding some money to be made, or software products which are based on media placement or ads. That would be sad if our next simulation products always had little ad windows in the corner, and that's how they got funded. So we should think about how these software partners can emerge. So a couple of thoughts. I mean, I think thought leaders should think about the path for software applications to grow. How can they grow? What steps do you take to facilitate emergence of new codes? We heard a lot about great work in new codes here. We have great representation today of people who do in-house codes. we seem a little thin on commercial ISV vendors here, and we could think about the reason for that. Those vendors need to make money. They need to find ways to sell their codes. And so how do we support that? Is there a kind of a pathfinding activity we can and should be doing? Is there sort of a, as you look at some of the research work you do, is there small companies you might try, or even new features of an existing vendor, to try and give them feedback and help them refine and tune and make their code better, a better model of reality, or supporting a university type research effort. But feedback is also a two-way street. We heard earlier issues with software holding back advancement of HPC. Licensing models are a concern. As I worked with ISV vendors, they have a challenge to hear their users and address common problems that users raise, such as how do I if I want to upgrade my workstation or add a new server node, can my license transfer over laterally at the same cost, the same budgetary point? So the budget of software licensing is often not well matched. Because you're adding cores doesn't really mean you're making a different economic decision about how you want to move your software. Also, the number one user concern I've heard really is, I'd like to expand my HPC work with a commercial ISV, but to do that I need to argue that I'm paying a reduced cost per job. If I want to double my cluster, I really want to run twice as many jobs, but I need to have that licensable in a way that I can show reduces my cost per job. Then I can motivate my upgrade and move across. And so that's a challenge for the software vendors, to hear their users and what they need to do to advance their user base, get more license seats sold. So that's my comments on the first point about supporting software business. My second point is some new developments I'll just highlight briefly in software technology that I think can advance parallel programming. Lots of the kids coming out of college these days, of course, have learned in a C++ or even sort of a web environment. Not a lot of Fortran is still being taught in universities. And so I saw lots of mention of MPI against various codes. There probably is a really thin number of people emerging from college who know what MPI stands for or how to spell it. There's other technologies that are out there, and I'm going to highlight two really briefly just because, A, they have great commercial options available, and they're in open source as well at the same time, and that's Silk Plus and TBB. They're both software offerings in the C++ environment. If you have a new code you want to build and you have a graduate student or a fresh college grad to look at it, I mean, C++ can give you some results. Silk Plus, which is a kind of an enhancement that Intel recently defined, and hitting the last point first, we've made it available in a GCC branch, so it is available in open source now to promote its usage. It's great for managing unequal work units. OpenMP and MPI often requires really carefully balanced units of execution. Silk Plus is aimed and can address unequal work units very flexibly. It has a few keywords to get it started. It's not hard to write code using Silk Plus and try it out. It also, as Intel extended it, has array notations borrowed from Fortran, and it can achieve great vectorization if you code it well. A gentleman I was speaking to earlier commented they'd done some work on C++ and got terrible performance results out of it. But in my view, I always argue that a compiler is like a violin. There are people who play it well and those who don't play it well. So if you can work well and understand the paradigms and what is the right construct to make it work well, we see and you can get great results from C++ and these new methods, and Silk Plus is both showing that in a great supported commercial available version and now an open source version available as well. So there are new alternatives to try and build new codes. The second one I want to mention has been around for a little while, but threading building blocks. It has got an amazing number of new ways of encoding parallel methods in it. For someone who wants to look at using C++ to build a code, this is something you should be considering. It has many models of parallelism, not just simple loop-level parallelism. It can handle unequal work units very, very well. The gentleman earlier gave a great, from Lawrence Livermore gave a great talk and talked about hierarchical need to break down the simulation, where they have unbalanced simulation work units being done dynamically on demand. So TBB is intended to support that kind of model. It has great load balancing features. It has a work stealing task scheduling method in it, and recently introduced a graph model to represent parallelism. So you can use a more kind of a message passing scheme, or as you're analyzing some kind of a flow graph, it does a good job of running parallel down through that graph. And it is available in open source format as well as a supported version. So that was my comments. So if there's sort of a call to action on this, I mean, Fortran's not the only answer, MPI is not the only answer. Consider some of the new parallel methods. They're available in production quality and have shown good results. Get parallelism into new places where it hasn't gone before. Engage new students who are more comfortable in C++. Our industry fundamentally needs new parallelism, new codes to drive forward. So that's actually my comments. That's it.